Okay, today we learned about special right triangles. So we're first going to review simplifying radical expressions, and then we're going to go over solving equations with radicals in it, and then we'll find the missing side lengths of any special right triangle. So here, remember we talked about when you want to simplify this, we need to get rid of that radical, and to get rid of that radical, we multiply the top and bottom by whatever is in that radical, because that's just like multiplying by 1. So we're manipulating that too, so that we can get rid of that radical. This is called rationalizing the denominator. So on the top you get root 3, on the bottom you get root 3 times root 3, which is the square root of 9. The square root of 9 is just 3. The next one, we're going to get rid of that root 5 by multiplying top and bottom by root 5. We're not worried about this 3 here, just the radical. So on the top you get 2 root 5. On the bottom you get 3 times, and then a root 5 times a root 5 is the square root of 25, which is just 5. And then we'll simplify that one more step. 2 root 5 over 3 times 5 is 15. The second one, this one's a little unique because there's a square root on the top and the bottom, and we talked about that if the indices are the same numbers, so these are both square roots, then we can actually go ahead and divide. This 5 divides into the 10 twice, and that simplifies as the square root of 2. Or you could go about rationalizing it and then simplifying it, but this is a much faster route. But to be able to do that, you have to have a number inside, and they both have to divide, and the index has to be the same. Okay, on example 2 we're going to solve each equation. So when we're going to solve, we want to isolate x, get it all by itself. So to isolate it, we divide by the square root of 3. And those divide out. And then we have 12 divided by root 3. So that's like our last problem. We want to rationalize that by multiplying top and bottom by root 3. So we get 12 root 3 over root 3 times root 3 is just 3. And then you can simplify this. The 12 is divided by the 3 4 times. So we get 4 root 3 is x. Okay, on B, to isolate the x, we're going to divide by the root 2. Those divide out. And then because these are both under of the radical and they both have the same index, then we can just go ahead and divide the 20 by the 2 and get root 10. On C, we want to isolate the x by dividing by 5. And the 5 and the 15 will reduce to give you 3 root 3. And that is as simplified as that gets. Okay, a right triangle, this is a review. We've talked about right triangles already, but it's a triangle that has one right angle. We have an isosceles right triangle. That's where one of the angles is a right angle and the other two are congruent angles, each 45 degrees. So I have one here, and I have that one of the legs labeled x. I'm going to say let's let x be 1. If that's 1, because it's isosceles, this side is also 1, and we're going to try to find c here. So we're going to take that 1 squared plus 1 squared equals c squared. We add 1 squared. 1 squared is 1. Add those together to get 2. And then to solve for c, we have to do the opposite of squaring, which is to take the square root. We get the square root of 2 is equal to c. And this is really important on a 45-45-90 triangle, because we can see that c is equal to root 2. We can say, hey, it's equal to 1 root 2, because it doesn't matter if there's a 1 there or not. So then we talked about, well, what if this side, instead of 1, what if it's 5? Well, it would make the other side 5, and it would make the hypotenuse 5 root 2. So then we said, well, what if this side, instead of being 5, what if it's 20? Then it would make our other leg 20, and it would make our hypotenuse, whoops, 20 root 2. So we talked about the hypotenuse on a 45-45-90 is always root 2 times bigger than the leg. Okay, to solve the right triangle, you must find all of the angles and all of the side lengths. In a 45, 45, 90, we already know the angles, so you have to find the 3 sides. So I did give some rules or some equations. In a 45, 45, 90, you know that your legs are equal. So I put L equals L, representing leg equals leg. And then we just talked about that the hypotenuse is always root 2 times bigger than the leg. So I'm going to put leg times root 2. And these two I'm going to ask you to memorize. The first one's a piece of cake. The second one is great, but it'll be a little bit more complicated a little bit later on in this lesson. Okay, so on example 3, you're going to solve each equation. To be able to solve it, you have to justify that you have a 45, 45, 90 triangle. Well, one of our angles is 45, so we know instantly that that angle is 45. From there, you want to identify the side that you have. Here we have a leg, so we know that instantly that our other leg is 12. And then we can use our formula to find the hypotenuse is our leg, in this case it's 12, times root 2. So our hypotenuse is 12 root 2. Now you could do the Pythagorean theorem, 12 squared plus 12 squared equals c squared, but this sure is a lot faster. Okay, on B we're going to look at it. It shows that we have congruent sides. So we know that these angles are congruent and they both have to be 45 degrees. And then we're going to say, hey, we're given the hypotenuse. So I'm going to use my formula that says my hypotenuse, in this case 15, is equal to my leg, root 2. So to solve for this, we're going to get rid of that root 2 by dividing. Those divide out. And then we also have to rationalize. So we're going to multiply the top and bottom by root 2. So our leg is equal to 15 root 2 over root 2 times root 2 will give you just 2. And then the 15 and 2 don't simplify nicely, so we'll just leave it as that fraction. Okay, on C again, you want to justify or figure out what kind of triangle you have. That's 45, so our other angle has to be 45. That makes this the hypotenuse. So to find the leg, we're going to say that the hypotenuse is equal to the leg, root 2. And to solve for the leg, we isolate the L by dividing by root 2. And we did one just like this. So we can divide those because they're both, they both have an index of 2. They're both square roots. So the square root of 20 divided by the square root of 2 is just 10, square root of 10. So both of our legs are the square root of 10. On our last one, we have a leg. We also have a 45-degree angle here, and so that we instantly know that the other leg is root 2. To find the hypotenuse, we take the leg times root 2. So we get 16, and then we have a root 2 times root 2 is just 2. And then when we multiply those, we get 32. So your hypotenuse is 32. Okay, now we're going to switch gears and talk a little bit about an equilateral triangle for just a few minutes. In an equilateral triangle, all the sides are equal and all the angles are equal, and so all the angles are 60. Now, when we cut an equilateral triangle in half, that's where that dotted line comes from. It does some things to our triangle. So here, it tells us that this side is 2, so that instantly means that side is 2. Well, when we cut it in half to create this triangle, our side here, which was 2, is cut in half to give us 1. And we're going to use this to find x here. So, because we have a right triangle, we can use the Pythagorean theorem. 1 squared plus x squared equals 2 squared. So 1 squared is 1, 2 squared is 4, we subtract 1 to get x squared equals 3. And we take the, or we do the opposite of squaring, which is to take the square root. So x is the square root of 3. So that was when the side was 1. What if I change this side and make it 10? Well, we can see that there's a relationship between the short side and the long, or the hypotenuse, the longest side. We can see that it's double. So if I make that one 10, then the hypotenuse has to be 20, which then would make my x value be x root 3 times my short leg times 1, which would be 10 root 3. Okay, if I change instead of being 10, if I said the short leg is 15, then the hypotenuse is twice as big, so that would make that one 30, and the longer leg is the square root of 3 times bigger, so it would be 15 root 3. Okay, so let's go see if we can come up with some rules. Again, to solve a triangle, you got to find all the angles and the side lengths. For a 30, 60, 90, I'm going to give you these formulas that the hypotenuse is our short leg times 2. Our hypotenuse was twice as big as our short leg. And for the second one, I'm going to use LL as our long leg is equal to our short leg times root 3. And those are the two formulas you're going to need to remember to use on a 30, 60, 90 triangle. So, again, we're going to look at your triangle and decide what you have. We do have a 60-degree angle, so that makes this one 30 because those acute angles are complementary. From here, what side do we have? We have 12. It's opposite the 30, which makes it the smallest side because it's opposite the smallest angle. So I'm going to call it the shortest side. So we actually have the shortest side. We need the hypotenuse. The hypotenuse is found by taking the short leg, in this case 12, times 2. That gives us 24. So this piece is 24. Our long leg is found by taking the short leg, which we have as 12, times root 3. And that's what our long leg is, 12 root 3. Okay, we go to B. Again, we have a 30-degree angle, so that tells us that this one is 60. And that's enough to tell us we have a 30, 60, 90 triangle. We need to identify the piece given. We have the hypotenuse, it's opposite the right angle. So we have the hypotenuse is equal to the short leg times 2. So to solve this, we would divide by 2, and 10 equals the short leg. So that would be opposite the 30-degree angle, so this is 10 up here. Once we know the short leg, it's easier to find the long leg. We take the long leg is equal to the short leg, which is 10, times root 3. So our long leg then is 10 root 3. Alright, here we go. We have identify the triangle. We know that this is 30, so we do have a 30, 60, 90. The piece that's given to us is the long leg. So we're going to use that formula that says the long leg is equal to the short leg times root 3. And to isolate the short leg or solve for it, we would divide by root 3. And they cancel over here, so we get 6 as our short leg. That turned out nice. From there we know that the hypotenuse is equal to the short leg times 2, which is 12. Okay, on D we have a 60-degree angle here, and 12 is opposite the 60-degree angle, so we know that 12 is our long leg. So we're going to use that long leg equation. Long leg 12 equals the short leg times root 3. And to solve this, we divide by root 3. And they divide out over here. We know that we cannot have a radical in the denominator, so we multiply by root 3, top and bottom. That gives us 12 root 3 over root 3 times root 3 is just 3. And then we can actually simplify this. 3 goes into 12 4 times. So our short leg is 4 root 3. Now, according to our formula, our hypotenuse is always twice as big as the short leg, so we take 4 root 3, multiply it by 2, and 2 times 4 is 8, so we get 8 root 3 as our hypotenuse. Alright, that should help you with your 12-3 special right triangles. Good luck.